Today we tackle the mysterious moon of Tora. Tora is the most notable moon in the Mantonian system for hosting exotic life. Now, a big part for Tora is its exotic life, but creating the right environment for exotic life is a real struggle. So rather than what we've done up till now, where I just made a cool world, I'll be constructing Tora exclusively based upon its exotic life's needs. For clarity's sake, when I refer to exotic life, I mean silicon-based chemistry as opposed to carbon-based chemistry. To put all of this into context, let's talk about silicon chemistry. Consider the following. While silicon is definitely the best pick when you don't want to use carbon, it still has some major issues. First of all, silicon-silicon bonds are very weak compared to carbon-carbon bonds, meaning complex silicon-based molecules shall be much harder to make. Secondly, silicon-oxygen bonds are almost 1.5 times stronger than carbon-oxygen bonds. Silicon dioxide, which is also known as quartz, is a much stronger molecule than carbon dioxide. Photosynthesis based upon silicon dioxide would be nearly impossible for plants to harvest their energy from, as they would struggle to obtain energy from such a reaction. Clearly, silicon-based life will not be as simple as replacing the carbon atoms with silicon atoms. Not that it ever was gonna, but you know. Silicon is a much heavier molecule than carbon, which makes its molecular bonds more troublesome to form complex molecules such as DNA and RNA. This in mind, we can already say that silicon-based life would profit immensely from being simple, unicellular organisms. Therefore, Toran life will be exclusively single-celled, due to the fact that silicon-silicon bonds simply aren't strong enough, separating it crucially from carbon, which can readily bond with other carbon atoms. So silicon-based life will find it difficult to evolve into more complex multicellular life. Silicon-based life is also unlikely to evolve in an oxygen environment. As mentioned previously, silicon-oxygen bonds are very strong, far too strong. They are so strong, in fact, oxygen would work like a poison on silicon-based life, as for their silicon would react with the oxygen to form silicon dioxide, which would halt their biochemistry and kill the organisms. Silicon dioxide, more commonly known as quartz, is an inorganic solid and would be a waste product to silicon-based life. It is very hard to exhale due to it being a solid. Silicon-oxygen bonds are so strong that you cannot simply separate silicon from the oxygen like plants do with carbon dioxide. Silicon-based photosynthesis is not feasible. Got that? Let's build. Tora is the second closest of the 6 moons to Manta. At 722,000 kilometers from the gas giant, it orbits Manta every 3 days approximately. It orbits with low eccentricity and inclination, in an all-by-all close but stable orbit. The moon has a diameter of 8,450 kilometers and a mass of 0.28 Earth masses, and thus experiences a surface gravity of 0.63 Gs, with an atmospheric pressure of 9.17 atm. This dense of an atmosphere has a huge greenhouse effect on the moon, causing the moon to have heated above the freezing point to a surface temperature of roughly 61 degrees. This heating is vital for exotic life to exist, as heat is a catalyst for the chemical reactions. Silicon, being much heavier than carbon, will need the heat to even get any silicon reactions going. Additionally, we will need to get rid of most of the oxygen in the moon's lithosphere. Remember, compounds containing silicon-silicon bonds will be damaged by reactions with any oxygen. Oxygen locks silicon into quartz, which has a melting point of over 1700 degrees. Never, ever expect to get silicon-based life working on a planet with a lot of oxygen. Two substances, water and ammonia, are very reactive with silicon chemistry, and we can't have any of that, so we need a liquid water and ammonia-free environment. But in these scenarios, another liquid would be needed to serve as a life solvent in their place. There are numerous alternatives suggested by scientists, but the only one that's liquid by the temperatures found on Tora is methanol. That's right, methyl alcohol will constitute the oceans on this planet, which will roughly cover 8% of the moon's surface. That's right, the wine oceans aren't a joke anymore. These creatures live in pure, raw alcohol. Welcome to the pub, baby. In addition, silicon tetrachloride is a close alternative. In addition to nitrogen, these two are also abundant in the Toran atmosphere, as even methanol is close to its boiling point on Tora. This can be compensated by increasing the pressure on the moon. With all these limitations, it's hard to imagine these life forms ever evolving multicellular. Any life on this moon will remain unicellular due to the chemical complications. For energy, it's likely to imagine these creatures utilize some chlorine-silicon reaction. The exact issue of what reaction has gone unsolved by scientists far more well studied than me, so let's just say some silicon-chlorine reaction gives them their energy and leave it at that. All with all, this will give us an atmosphere composed mostly of nitrogen, chlorine and some methane. The 61 degrees at the surface will likely still be insufficient to support these creatures though, as most of these reactions only become exothermic at 300 degrees or above. So these life forms will thrive in extreme hyperthermal conditions, possibly near volcanic vents or underground caves on the moon. What I envision these organisms to look like are colonies of yellowish slime, found primarily in hot underground caves or volcanic vents. As for a name, I'll call them Silicus torana, which sounds cool. I may or may not, but probably will revisit these creatures in the future if more detailed research of silicon-based biochemistry presents itself. But for now, this will do. This moon didn't really have a base, so please forgive the inevitable inaccuracies. Just to point this out now is that when I finish the system, I'll do a fully fledged Q&A and we can discuss all of it in further detail if you guys want so. So I really hope I did a good job explaining the thought process behind it. As you can imagine, the chemistry is quite alien, so that's why the video took a little longer to make as well. As always, you're welcome to join the Discord and share your own world buildings. Next up is Siana. Stay tuned.